Hello dear grade 9 students, welcome back, and here we'll go with the second part of trigonometric relations, which is about identities. We're going to talk about trigonometric identities. The most famous trigonometric identity is cosine squared x plus sine squared x equals to 1. This is a totally new idea and we're going to prove it in the next slide, and you are going to be familiar with it. First of all, you'll see it like difficult a little bit, but later you will be familiar and it will be so easy according to you. Now the second one is not that important, it's just like a remark. It's tangent x times cotangent x equals to 1. This is so clear because you know that cotangent x is the reciprocal of tangent x. So as if I'm writing that tangent x times 1 over tangent x. So I replace cotangent by 1 over tangent x, then I can cancel tangent with tangent and definitely I'm going to get 1. So what's important now is the proof of this relation. Where did this relation come from? And here we go in the next slide. As you remember, when we talked about trigonometry, we used a right triangle, and if you remember, there was an acute angle that's called x, or sometimes we call it alpha. Now let's apply the rules we learned about in the previous videos, in the previous parts. The rule says that cosine of x is equal to the adjacent side to x, which is here AB, over the hypotenuse, which is here BC, and sine of x is equal to the opposite side of x, which is AC, over the hypotenuse, which is BC. Now we are going to use these rules in order to prove this important identity. And here is the proof. If you evaluate, as I told you, cosine x by AB over BC, the adjacent over the hypotenuse, and sine x by the opposite over the hypotenuse, which is AC over BC, and then because you have a square here, then you should put a square here and a square here, because you have cosine squared plus sine squared. Then because you have a fraction, you can introduce the power like this and like this. Then definitely you're going to get AB squared over BC squared plus AC squared over BC squared. Now putting them on the same denominator, because you notice that the denominator is the same, then you will get AB squared plus AC squared, which is BC squared over BC squared, which is 1. Where did this BC squared come from? Where did this come from? Who told me that AB squared plus AC squared is BC squared? Let's see. It came from Pythagoras. Okay? Pythagoras theorem says that AB squared plus AC squared equals BC squared, the hypotenuse squared. So all what I did is to substitute AB squared plus AC squared by BC squared, and thus I will get 1. And hence, this famous identity is proved using the definitions of the sine and the cosine in the right triangle. Let's now make training exercises and see what we are going to get from this important identity. The most famous identity again in trigonometry is cosine squared x plus sine squared x equals 1. From this identity, I can discover two other identities. The first one is that sine squared x is 1 minus cosine squared x. Actually, this identity and this identity are the same, because all what I did is that taking cosine squared x to the other side, then I will get sine squared x equals to 1 minus cosine squared x, and in the training exercises, you are going to know when to use this one, okay? And the other one is about cosine squared x, and it's equal to 1 minus sine squared x, as if I take sine squared x to the other side to keep cosine squared x alone, and thus I will get that cosine squared x is equal to 1 minus sine squared x. Keep them in mind, we are going to use them every time we need to prove identities. And here we start with the training exercises. Establish the following, or we can say prove the following, or verify the following, or show that, or whatever. So we have to prove that cosine x plus sine x, all of it squared, is equal to 1 plus 2 sine x dot cosine x. Let's get started. Okay. Here, if you remember, using the identity, I can expand this using the identity that says, first of all, I'm going to name this side 1 and this side 2. So to establish this identity or this equality, I have to prove that side 1 is equal to side 2. So let's start by side 1. Okay? Using the expanding identity, I can write cosine squared x plus 2 cosine x dot sine x, they are multiplied. Okay, I make squaring of the first one, then I 2 times their product, plus sine squared x. So pay attention, you don't have, it's not allowed for you to introduce the power like this. That's wrong, because you have a plus sign inside, so you cannot introduce the power. So pay attention for this, you just apply the identity. Let's continue. So I will get cosine squared x plus 2 cosine x dot sine x plus sine squared x. It starts resembling the second side, but I have to get rid from cosine squared x and sine squared x. 2 cosine x dot sine x is the same as 2 sine x dot cosine x. But I have to have 1 instead of cosine squared x plus sine squared x. How does that happen? Let's remember. The identities say that cosine squared x plus sine squared x is 1. And I have these two. Which one of these I'm going to use? I'm going to use the first one. So I have to replace cosine squared x plus sine squared x by 1. And thus I will get 1 plus 2 cosine x dot means times sine x, which is exactly like the other side, and thus this identity is established.